In this lesson, we will learn about additional features of Rapid Spanning Tree Protocol. As you may know, Rapid Spanning Tree Protocol introduced multiple spanning trees. Therefore, let's find out why we need multiple spanning trees. To answer this question, let's analyze this network diagram. In this network, we have two VLANs, VLAN 10 and VLAN 20. There is only one common spanning tree for this network. Here is the current MSTP status. With one spanning tree, the network traffic between the client and the server in VLAN 20 like this. However, the network traffic between the client and the server in VLAN 10 like this. You can easily recognize that the network traffic in VLAN 20 is optimal, but VLAN 10 is not. There is a need for multiple spanning trees to make IT Live Skill Switch 2 is a root switch for VLAN 10 and IT Live Skill Switch 3 is a root switch for VLAN 20. The need for multiple spanning trees has led to the development of the various MSTP family of protocols. Let's look at this timeline. MSTP was first released back in early 1990s. It created a common spanning tree for all VLANs. By mid-1990s, Cisco created the MSTP-based per VLAN spanning tree plus PVST plus protocol, which creates one spanning tree instance per VLAN. In 2001, the IEEE introduced RSTP and multiple spanning tree protocol. Not long after that, Cisco created Rapid per VLAN spanning tree plus RPVST plus protocol. RPVST plus provided more features than standardized RSTP, including one tree per VLAN. Now let's analyze how Rapid Spanning Tree Protocol implements multiple VLANs via bridge ID. As you may remember, bridge ID contains two fields. The priority field has 2 bytes and the system ID field has 6 bytes. To implement multiple VLANs, the priority field is shortened into 4 bits. It occupies the leftmost part, therefore its value must be a multiple of 4096. The remaining 12 bits part is called extended system ID. When a PPDU is generated for a VLAN, the VLAN ID will be inserted into the extended system ID. The values of the priority field and the extended system ID field are added together to make the priority value. For example, we configure the priority of a switch as 49152. In VLAN 10, the priority value is 49162. Finally, the universal burn-in MAC address is plugged into the system ID field. That is how Rapid Spanning Tree Protocol implements multiple VLANs. Let's configure RSTP for the switches in this network. Currently, IT Live Skill Switch 1 is a root switch. Let's configure STP mode. In order to configure STP mode, at the switch configuration mode, we issue the command spanning -3 mode, and then we put in a question mark, then hit enter. It will show us the three modes that we can configure for STP. The first one is MST, which is multiple spanning tree mode. The second one is PVST, which is per VLAN spanning tree mode. And the last one is rapid PVST, which is per VLAN rapid spanning tree mode. Let's do it in IT Live Skill Switch 1. Here we are at the privilege mode. Let's do the command show spanning -3 VLAN 10. As you can see, the protocol in use is RSTP. However, we see that it uses extended system ID for VLAN 10. So this is actually the rapid PVST or per VLAN rapid spanning tree mode is being used on IT Live Skill Switch 1. Let's go to the configuration mode and issue the command spanning -3 mode, and we put in the question marks. As you can see, these are the three modes that we can configure on IT Live Skill Switch 1 for STP. However, the current mode is rapid PVST, so we don't make any change in the configurations. Let's configure priority for a VLAN. In order to configure priority for a VLAN, at the switch configuration mode, we issue a command spanning tree VLAN, then we put in the VLAN number, then priority, and put in a question mark, then hit enter. It will show us the range of the priority must be from 0 to 61440, and the bridge priority in increments of 4096. Let's configure the priority on IT Live Skills Switch 1. First, we need to go to the configuration mode, then we issue the command spanning tree VLAN 10 priority, and we put in the question marks, then hit enter. Now we set the priority for VLAN 10 is 49.152, and we hit enter, and that's it. Let's show the configuration. Show spanning tree VLAN 10. Now you see that the priority for VLAN 10 in IT Live Skill Switch 1 is 49.162, because the priority is 49.152 and the VLAN which inserted into the system ID extension is 10. So these two numbers are added together to make the priority 49.162. In rapid spanning tree protocol, you can quickly make a switch become the primary root switch for a VLAN. In order to do that, at the switch configuration mode, we issue the command spanning tree VLAN, then we specify VLAN number with the keyword root primary, then hit enter. This command is actually a script, and here is how it works. Let's make IT Live Skill Switch 1 become the root switch of VLAN 10. From the show spanning tree VLAN 10 command, we can confirm that IT Live Skill Switch 1 is not the root switch in VLAN 10, and it has a priority 49.162, and the current root switch have the priority 32.778, which is greater than 24.576. So after we issue this command, it will set the priority value of the IT Live Skill Switch 1 to 24.576. Let's do it. Here we are at the configuration mode. We need to issue the command spanning -3 VLAN 10 root primary, then hit enter, and that's it. We X out this and show spanning tree VLAN 10. As you can see, Active Live Skill Switch 1 now becomes the root switch, and it has the priority value 24.576 in VLAN 10. So the priority value of the Active Live Skill Switch 1 in VLAN 10 is 24.586. You can also configure a switch to make it the secondary root switch. This switch will take the role of the root switch when the root switch is down. In order to do that, at the switch configuration mode, we issue the command spanning tree VLAN, and then we specify the VLAN number and the keyword root secondary, then hit enter. This command is also a script, and here is how it works. Let's do it on IT Live Skill Switch 2. Here we are at the privilege mode, and we issue the command show spanning tree VLAN 10. And as you can see, the IT Live Skill Switch 2 have the priority value of 32.778. Let's go to the configuration mode, and we issue the command spanning -3 VLAN 10 and the keyword root secondary, then hit enter, and X out this and show spanning -3 VLAN 10. Now, as you can see, the priority value of switch 2 is 28.682 because the priority value is 28.672, and in VLAN 10 the sum of these two values will make it 28.682. In Rapid Spanning Tree protocol, we can change the cost of a port for a specific VLAN. In order to do that, we first need to go to that interface, and here we are at the interface configuration mode. We need to issue the command spanning -3, then we provide the VLAN information with the keyword cost and put in the question mark, then hit enter. It will show us with the range of the value that we can set for the cost. Please note that if we do not provide the VLAN information, it will set the cost for the port for all VLANs. Let's change the cost for the port E01 to 10 in VLAN 10 on IT Live Skill Switch 2. Here we are at the privilege mode. We need to go to the configuration mode. Then we go to the interface E01 and issue the command spanning -3 VLAN 10 cost 10, then hit enter. Now we verify it by using the command show spanning -3 VLAN 10 interface E01. As you can see, the cost for the port E01 is 10 for VLAN 10. We can also use the command show spanning -3 VLAN 10. As you can see, it shows us the cost from the IT Life Skill Switch 2 to the root is 10. Let's perform Wireshark analysis on the packet captured on a chunk link for IT Life Skill Switch 2. First, the protocol version in use is Rapid Spanning Tree. Next, the destination multicast address is this. It also identifies the originating VLAN. And when the PPDU is sent over the 802.1q chunk link, it also identifies the VLAN ID. So in conclusion, the mode in use is Rapid per VLAN Spanning Tree Plus. Please read the keynotes for this lesson.